Hi, my name is Graham Smith, and I'm one of the authors that helped develop the learning approach to mathematics that is found in our textbook as well as the video you are about to experience. To learn more about our approach to learning mathematics, visit the web address that accompanies this video. Now, enjoy the video. Adding and subtracting fractions. This video will help you add and subtract like fractions, build like fractions by listing multiples, add and subtract unlike fractions by listing multiples, build like fractions by factoring, and add and subtract unlike fractions by factoring. Add and subtract like fractions. Let's start with a definition. Like fractions have the same denominator. 1/4 and 2/4 are like fractions because they have identical denominators. Since both of these fractions are fourths, they are the same kinds of fractions, and we can add them together. So down here, I have 1/4 plus 2/4. Well, I can add those fractions together because they're both fourths to give us a total of 3/4. This is very similar to adding other like objects together. We can take a look at money. If I have $1 plus $2, I end up with $3 in totals. In both of these situations, I'm adding the same kinds of things together. So when we add like fractions together, the denominator stays the same because the denominator tells us the type of fraction or the type of thing that we're adding together. Now let's take a look at some examples that will help us understand how to add and subtract like fractions. Example 1. Add 4/10 plus 2/10. Since these fractions have the same denominator, they're the same kinds of fractions, and we can add them together to get a total number. 4 of these tenths plus 2 more of these tenths altogether will give us 6/10. Now we're not done yet because the fraction 6/10 can be simplified. And to simplify that, we factor both the numerator and denominator. When I factor 6, I get 2 times 3. When I factor 10, I get 2 times 5. We'll divide out the common factor of 2, giving us a final simplified answer of 3/5. Example 2. We're going to subtract 4/6 from 5/6. If I start with 5 of these 6 and I take 4 of these 6 away, I'm going to be left with 1/6. 1/6 cannot be simplified, so that's our final answer. Now it's time to check your understanding of adding and subtracting like fractions. Hit pause on your video player and answer these 2 guided practice questions. When you're done, hit play to see how you did. Question 1. Add 4/9 plus 2/9. If I add 4 of these 9s plus 2 more of these 9s, I get 6/9. We're not done because 6/9 can be simplified. When I factor 6, I get 2 times 3. When I factor 9, I get 3 times 3. Divide out the common factor of 3, get a final simplified answer of 2/3. Question 2. Subtract 3/8 from 5/8. If I start with 5 of these 8s and I take 3 of them away, I'll end up with 2/8, and that could be simplified. 2 is already a prime number. However, 8 can be factored. When I factor 8, factors into 2 times 2 times 2. Divide out the common factor of 2. I get a final simplified answer of 1/4. Build like fractions by listing multiples. Let's start with some definitions. Unlike fractions are fractions that have different denominators. The least common denominator, or LCD, of several fractions is the least common multiple of their denominators. 1/6 and 5/9 are unlike fractions because their denominators are different. We cannot add or subtract these fractions as they're written. If I try to add 1/6 to 5/9, I'm adding fractions that have different size pieces. In the first fraction, the pieces are 6ths. In the second fraction, the pieces are 9ths. They're different size pieces. Therefore, they're different things, and we can't add different things together. To add these fractions together, We must find the least common denominator, or LCD, and then build them into like fractions so they have denominators that are the same. Now let's take a look at some examples that will help us build the fractions 1/6 and 5/9 into like fractions so that we can add these fractions together. Example 3. Identify the LCD, or least common denominator, of 1/6 and 5/9 by listing multiples. Well, the least common denominator is just the least common multiple of these two denominators. So I'm looking for the least common multiple of 6 and 9. Well, let's start listing multiples of these numbers until we find the first one they have in common. Multiples of 6. 6 times 1 is 6. 6 times 2 is 12. 6 times 3 is 18. Times 4 is 24. I'm going to stop right there and see if I have already found a common multiple. If not, I'll keep listing some more. Let's go to 9. 9 times 1 is 9. 9 times 2 is 18. I can stop. They both have a common multiple of 18. That's the first multiple they have in common, so that makes it the smallest multiple they have in common. So the LCD of these two fractions is going to be 18, because that is the first multiple these two denominators, 6 and 9, had in common. Example 4. Build 1/6 and 5/9 into like fractions. You can see that I have a framework set up here for each of these fractions. Let me talk a little bit about the framework I have set up. We'll take the original fraction, 1/6, and the other fraction, 5/9. Write those down. What we're going to do now is we're going to multiply by some fraction here in the middle. We don't know what that fraction is yet. We're going to multiply by this fraction, and it's going to give us our new denominator, which is the least common denominator of 18 that we got from example 3 above. So we've done the same thing over here for 5/9. We're going to take and we're going to multiply by some fraction here, and we want to get a new denominator, the common denominator or least common denominator of these two fractions. Let's take a look at 1/6. Well, 6 times what is going to give us 18 for the denominator? Well, 6 times 3. So that's going to go in the bottom of this fraction. Now I also want to put a 3 in the top of this fraction. The reason I want to do that is because 3 over 3 is equal to 1. So really what I'm doing here is I'm taking 1/6 times a fraction that's equal to 1. So I'm not going to change the value of 1/6. I'm just going to change the way it looks. And so when I take 1 times 3 in the top, I get 3/18. And now 3/18 is equal to 1/6. So in the next step, I can replace 1/6 with 3/18. Doing the same thing with 5/9. 9 times what will give me 18? Well, 9 times 2. And I multiply the top by the same number, which gives me a new equivalent fraction of 10/18. Example 5. Add 1/6 and 5/9 together. Well, we already decided these fractions are unlike fractions. We can't add them together as they stand, but we can replace these fractions with the new equivalent fractions we found in example 4. So 1/6, we can replace that with 3/18, because 3/18 is equal to 1/6. And now 5/9, I can replace that with 10/18, because 10/18 is equal to 5/9. Now I have fractions that are like fractions because they have the same denominator, 18. Now I have like fractions, I can add them together. 3 of these 18ths plus 10 more of these 18ths will give me 13/18. Now 13 and 18 don't share any common factors, so that is our final simplified answer. Now it's time to check your understanding of building like fractions by listing multiples. Hit pause on your video player and answer these 3 guided practice questions. When you're done, hit play to see how you did. Question 3. Identify the LCD of 2/3 and 1/4 by listing multiples. Well, we're looking for the first multiple that 3 and 4 have in common. If I take multiples of 3, I'll get 3, 6, 9, 12, 15. That's enough. I'll stop right there and I'll start listing multiples of 4. Multiples of 4. 4, 8, 12. I can stop. They both have a multiple of 12 in common. That's the first multiple they have in common. Therefore, it's the smallest or least multiple they have in common. So the least common denominator for 2/3 and 1/4 is going to be 12. Question 4. Build 2/3 and 1/4 into like fractions. Okay, I've set up the framework now. I take the original fractions, 2/3 and 1/4. I'm going to multiply them by something to get this new denominator of 12, the least common denominator for these fractions. Let's start with 2/3. 3 times 4 is going to give me that new denominator of 12. So I want to multiply the top by the same number so that I make sure I'm multiplying by 1 here. 2 times 4 is 8/12. Now with 1/4, 4 times 3 is going to give me that new denominator of 12. I multiply the top by the same number. 1 times 3 gives me a new fraction of 3/12. Question 5. Subtract 1/4 from 2/3. Well, we can't subtract these fractions as they stand. They don't have the same denominators or common denominators. But we can replace them with our new like fractions that we built in question 4. So let's see. 2/3, we're going to replace 2/3 with 8/12. That is a new equivalent fraction for 2/3. And we're going to subtract from that the new equivalent fraction for 1/4 is 3/12. Now I have like fractions with the same denominators, so I can subtract. 8/12, if I take 3/12 away from 8/12, I'll be left with 5 of these 12s. 5 and 12 don't share any common factors, so that's our final simplified answer. Build like fractions by factoring. Listing multiples to build like fractions, like we did in the last examples in guided practice, can be very time consuming when the fractions have large denominators. For many fractions, it's easier to find the LCD by factoring. Now let's take a look at some examples that will help us build like fractions by factoring. Example 6. Build 7/12 and 5/14 into like fractions by factoring. Well, let's take a look at these two denominators, 12 and 14. Those are difficult denominators to work with, so it is going to take us a little bit of steps to find our common denominator here. So here are the steps. The first thing we want to do is we want to factor each denominator. So let's start with 12. The prime factorization for 12 is 2 times 2 times 3. And if you want to verify that, go and check that on scratch paper. The prime factorization for 14 is 2 times 7. All right, so I factored each of the denominators. Now I want to fill in the Venn diagram. Let's draw a Venn diagram. Okay, now the factors they have in common are going to go in the overlap here. Well, let's take a look at the factors they have in common. Looks like they have a common factor of 2. So I want to write that into the overlap. Now I want to fill in the rest of the Venn diagram. The other factors for 12 are 2 and 3. The other factors for 14 are 7. Once I have my Venn diagram filled in, the LCD, the next step is that the LCD is all of the factors multiplied together. So my LCD is going to be all of these factors multiplied together. So it looks like 2 times 3 times 2 times 7. When I multiply those together, 2 times 3 is 6, times 2 again is 12, and then 12 times 7 is 84. So my least common denominator then is 84. Now that I found the LCD, the next step is to build like fractions. So I'm going to take my original fractions, 7/12, I'm multiplying by something to get a new denominator of 84, and I want to take my other fraction, 5/14, and multiply to get a new denominator of 84. Well, I'm going to have to figure out what my missing multiplier is in each of these cases. The Venn diagram can help us do that. If I take a look at 12 and I look back up at the Venn diagram, the only factor that is outside of the circle for 12 is 7. So that's going to be my missing multiplier here. So I can put 7 down here into my framework, and 12 times 7 of course is going to give us 84, and then in the numerator 7 times 7 gives us 49. Let's do the same thing for 14. Well, there are two factors outside of the circle for 14, both the 2 and the 3. If I multiply those together, that's going to give me 6. So 6 is going to be my missing multiplier here. And when I multiply the numerators together, 5 times 6 gives me a new equivalent fraction of 30/84. Example 7. Subtract 5/14 from 7/12. Well, we're going to have to replace these fractions with the new equivalent fractions we found in question 6. So let's see, 7/12 is going to get replaced with 49/84. And we're going to replace 5/14 with 30/84. Now I have like fractions. Both have the same denominator, so now I can subtract. 49, take 30 away from 49, that's going to give us 19/84. Well, 19 is a prime number, and it is not a factor of 84, so 19 and 84 do not share any common factors, so that is my final simplified answer. Now it's time to check your understanding of building like fractions by factoring. Hit pause on your video player and answer these 2 guided practice questions. When you're done, hit play to see how you did. Question 6. Build 4/15 and 1/25 into like fractions by factoring. Well, the first step is going to be to factor each denominator. I get 3 times 5. And if I factor 25, I get 5 times 5. Step 2, fill in the Venn diagram. Step 2, fill in the Venn diagram. Well, the factor that they have in common is 5, so that's going to go in the overlap. 15 has a factor of 3. 25 also has another factor of 5. Step 3, the LCD is all of these factors multiplied together. So let's see, I'll multiply 3 times 5 times 5. When I multiply those all together, 3 times 3 is 15, and 15 times 5 is 75. Step 4 is to build like fractions. So I'm going to take my original fraction, 4/15, multiplying it by something to get this new denominator of 75. Same thing with 1/25. I'm going to multiply it by some fraction to get this new denominator of 75. Well, let's take a look at the Venn diagram to find the missing multiplier for 4/15. The denominator is 15. It looks like the only factor outside of the circle for 15 is the 5. So that is my missing multiplier. So 15 times 5 gives me 75 in the denominator, and 4 times 5 gives me 20 in the numerator. 1/25. Well, for 25, it looks like the only factor outside of the circle for 25 is 3. So that's my missing multiplier there. And 1 times 3 gives me 3/75. Question 7. Add 4/15 plus 1/25. Well, we can't add them currently because they're not like fractions, but we can replace them with the like fractions we found in question 6. So we're going to replace 4/15 with 20 over 75, and we're going to replace 1/25 with 3/75. Now we have like fractions, so we can add these together. If I start with 20 of these 75ths and add 3 more of them, altogether I'll have 23 75ths. Now 23 is a prime number. It's not a factor of 75, so these don't share any common factors. So that is my final simplified answer. If you found this video helpful, I encourage you to check out our other videos that we have on YouTube, or visit the web address that accompanies this video to learn more about our approach to learning mathematics.